So we're looking at pyramids today. Do you know what the vertex of a pyramid would be? The little tip top, yes. The common vertex of the pyramid's lateral faces. What are the lateral faces? Yeah, the faces on the side, and they all meet up at one point up at the top. That's the vertex, okay? We're usually going to look at regular pyramids because they're a lot easier. You can do other ones, but what they're mainly going to give you are regular, okay? So it's a pyramid with a regular polygon. Has a regular polygon as the base. That's where it gets the name regular from, the regular base. And with lateral faces, that are congruent isosceles triangles. So you have a regular pyramid. It has some kind of regular base. Triangle, square, pentagon, hexagon, they're all regular. And then all of the sides are the same. So if you find the area for one lateral side, you just multiply it by however many you have. Does that make sense? Okay. Slant height. You know what the slant height's going to be? If you look at this, it's not an actual pyramid, but the slant height is from the vertex down to the base. Does that make sense? Just like on a cone. Have we done cones this year? Have we done those yet? Not yet? Okay. Well, it'll be the same on the cone. But if this is a flat face, and this is flat, the slant height's from the tip top down to the middle of the face. Does that make sense? So yeah, it's the height of the triangle. But the slant height and the height of the pyramid are not the same. Does that make sense? The height is measured from the vertex all the way down to the base, not to the edge. Does that make sense? You might smell that there. I think I just need to leave it open one weekend, but I'm worried I might come back and my room would smell like that. Like old person that hasn't been cleaned in forever. All right, so your lateral surface area, 1/2, your perimeter times L. L is your slant height. P is obviously perimeter. Or if you forget that formula, you can just find the area of each of the triangles, because that's what the lateral faces are going to be. Any questions so far? Okay. So we want to find the lateral area of the regular hexagonal pyramid. Why do you think it's called a hexagonal pyramid? The base is a hexagon, yeah. If you were ever unsure of a formula, they're back in your textbook, like for volume, surface area, that kind of thing, on page 803. So if you're ever trying to look back at your formulas, if you can't remember what lesson we did, it's on page 803. Just flip towards the back. It's right before the glossary. Well, no, not the glossary. Before the postulates and theorems, which is right before the glossary. All right, so what would I do to find the lateral surface area for this? Okay, what would be our perimeter? How did you get 18? 3 times 6, yeah. So our area, 1/2 times 18 times 9, which is? Y'all see how that works? Any questions there? Okay. Looking at the surface area for a regular pyramid. The total surface area, you do your lateral surface area, and then you add the area for your base. Is there really a need for you to draw the pyramid? If you want to, can you? I think pyramids are the hardest figure to draw. I don't know why. That's just me personally. You may think they're easy, but I try to avoid having to draw a pyramid if I can. So unless I really need it, I don't draw the pyramid. But if you really need it, then go ahead and draw it. If it helps you get it right, spend the time. If you don't need it, then there's no point in wasting the time drawing it. Does that make sense? All right, so we want to find the total surface area. Well, first we need to find our lateral surface area, right? What numbers would I use for the lateral surface area? Okay, 5 times 6 because why? Side length, and you have 6 sides. Okay, what else? Because that's the slant height. Does that make sense so far? Okay, so I get my lateral surface area, and what do I need now? The base. Alright, so this is what my hexagon looks like. How am I going to find the area of this? Apothem. Yes, this is our apothem. So I'm going to draw my triangle. What is this angle right here? So what does that angle have to be? Does that make sense? Okay. How long would this be? What would be the length of my apothem? Do what? Yes. Does that make sense? Any questions on that part? Okay, so what would I do to find the area of this? You remember the formula for these? It has an apothem in it. 1/2 the apothem. Did you say from perimeter? Yes. Does that make sense? Okay, so plus 1/2. Well, our apothem is 2.5. I'm going to write it as 5/2. And then what is our perimeter? 30. You see how that works? Okay, so half of 30 is 15 times that is 165. Five over 4 times 30. But that reduces to 75 over 2. Did y'all put it in a decimal? Did you get about 230 if you put it as a decimal? 125. No, because 165. Are you talking about for the 70? Oh, you're talking about that. No, you shouldn't get 125. You gotta divide it by 2. Did you just do 75 squared to 3? Oh. I think you forgot the 1/2 part. Or the divide by 2. I don't know which one. Because it was like twice what it should be. Do y'all see how that works? And then our units would be meters squared. Any questions there? Okay. Looking at the volume for regular pyramids. One-third base times height, area of the base times the height. This is the same formula that you'll use for a cone. Both a cone and a pyramid, they meet at a point. You find the area of the base, multiply it by the height, and divide by 3. Always 1/3. 1/3 base times height. Can you tell what the pyramid's base is? A triangle? Okay. Any ideas what our height would be? No, for the volume formula, for the height, what would it be? None? Do you agree with that? Is it going from the base, like the middle of the base to the top? Okay. What about the area of the base? How would we find that? 8 times 5 divided by 2, because it's a triangle. Does that make sense? Do I need to go over any part of that? Okay. What did you get for your volume? Does that make sense? Any questions on the pyramid? Okay. Looking at the last one. Does it look like a square? But not really. It looks more like a rectangle, but they tell you it's a square. Okay? So look at what they tell you before you start assuming things about the picture. Good question. How do you get the slant height? What do we know about the figure? Yeah. And we know that the height is 3, right? What is the length of this right here? Half of 4.9, which is 2.45. Does that make sense? And then our slant height is like that. It makes the right triangle. And you can use Pythagorean theorem to find your L, your slant height. Does that make sense? You'll have to use that information quite a bit. Do y'all understand how it works? Okay. So if they don't give you the slant height and they only give you the height, don't say, oh, well, they must have mislabeled it. They're telling you the height so that you can find the slant height. Have y'all all gotten your slant height? What did you get for your slant height? 3.87? Square root of 9 plus 2.45 squared. Okay, so we're looking for our lateral surface area. What formula do we use? What would be the perimeter for this? And then 3.87 is our L. Does that make sense? So it says round to the nearest square foot. So if you look at your answer, what would you write? 38 feet squared. Any questions here? Do you have to learn the formulas for volume and surface area? Yes. What's the surface area formula? Like the whole surface area formula? Okay, how do you find the lateral surface area? Okay, how would you find the area of a base if it's not a square or a triangle? AP, 1/2 A times perimeter. And then how do you find volume? 1/3 area of the base times the height. Any questions on pyramids? Okay, go ahead and clear your desk for your test corrections.